Okay, now we'll actually define what it means for a function to be continuous at a point. So we say a function is continuous at a point A, and A is an x value, if the limit as x goes to A of f of x equals f of A. So we're kind of saying that it's continuous when that limit, you're able to just do just direct substitution, that the limit is equal to the function value there. Now, to test if a function is continuous at A, we kind of have to test three things, and these should kind of make sense. First of all, f of A must exist. Okay, so if A is not in the domain of your function, you can't be continuous there. Second, your limit as x goes to A of f of x must exist. Okay, so if your limit doesn't exist, if your left-handed and your right-handed limits aren't the same, then you might have something like a jump discontinuity or an asymptote. You wouldn't be continuous there. And finally, these two things not only have to exist, but they have to equal each other. Okay, so it's possible that they would both exist, that you would have a limit and you would have a function value, but they might not be equal. So if they're equal, then you're continuous at that point. Okay, we say a function is continuous on an interval if and only if it is continuous at every point on the interval. Okay, so if you have, maybe you can say you're continuous from 5 to 7, and that just means every point between 5 and 7 you're continuous. Okay, and then we just say a function is continuous if and only if it's continuous at every point in its domain. Okay, so if it's continuous everywhere that it exists, then we can just call it a continuous function. And we'll talk about functions that are continuous in just a minute.